Okay, so section 4.4, we're going to talk about area of triangles. So in any triangle, the area is given by 1/2 the base times the height, where b is the length of the base and h is the length of the altitude that's drawn to that base. Now, if we have an oblique triangle, then the altitude is going to come from one of the angles to the base opposite that angle. So for instance, if we call the altitude h and we're looking at angle A, then we can say that h over c is equal to the opposite over hypotenuse of angle A. So that would be the sine of A. And if I solve this equation, h over c equals sine of A for h, by multiplying both sides by c, then what happens is the c's cross out on the left hand side, and I get that the height or the altitude of that triangle is side c times the sine of angle A. And so if I replace that into the area equals 1/2 BH formula, I get that the area is 1/2 B times C sine A, or 1/2 BC sine of A. And so that gives us a new formula for the area of a triangle, so long as we know two sides and the angle between them. And that is that the area is either going to be 1/2 BC times the sine of A, or 1/2 AC times the sine of B, or 1/2 AB times the sine of C. And so we're going to use one of these three formulas to find the area of an oblique triangle, knowing two sides and the angle between the two sides. So for example, here we've got the triangle ABC. We know side A is 18 feet, side C is 20 feet, and angle B, which is the angle between them, is 38 degrees. So the area of this triangle is equal to 1/2 A times C times the sine of angle B, or 1/2 times 18 times 20 times the sine of 38 degrees. So that's 180 times the sine of 38 degrees. And so if I take that and I plug that into my calculator, so I plug that into my calculator, 110 square feet. And so that's how we find the area of an oblique triangle if we know two sides and the angle between them. So let's look at another one. Here's triangle ABC. This time I know two angles and the side. So what I need to do here is first I need to find side C. And so angle C is going to be 180 degrees minus the sum of A plus B. Because when you add the three angles of a triangle up together, you get 180 degrees. So A plus B plus C equals 180. So C is going to be 180 minus A plus B, and A plus B is 100 plus 20. So angle C is 180 minus 120. So that's a 60-degree angle. And so if I know angle C is 60 degrees, then I can use the law of sines. C over sine C equals A over sine A to find the length of side C. And then once I have side C, then I can plug it into the area formula and get the area. So in this case, side C is equal to A times the sine of angle C divided by the sine of angle A. So that's going to be 10 times the sine of 60 degrees divided by the sine of 20 degrees. And when I plug that into my calculator, I get side C is 25.3 centimeters. And so now I can find the area as 1/2 AC times the sine of angle B. So A is 10, C is 25.3, and angle B is 100 degrees. And so when I plug that into my calculator, I get the area of that triangle is 124.58 square centimeters. So sometimes you have to use the law of sines to find the side that you need to be able to plug into the formula to get the area. Okay, so that's how we find area of oblique triangles that are side angle side case. Now, what if I know the length of the three sides? Well, if I do, then I use something called Heron's formula. And so that's based on something called the semi-perimeter. And the semi-perimeter is just half of the sum of the lengths of the sides of the triangle. So if the semi-perimeter is a half times A plus B plus C, then Heron's formula for the area of the triangle is going to be the square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. And so they'll give you all three lengths of the sides, and you just have to plug into this formula to get the semi-perimeter, and then this formula to get the area. Okay, so here's an example of this. I've got triangle ABC. A is 8 meters, B is 6 meters, and C is 4 meters. And we want to use Heron's formula to find the area of this triangle. So first thing I'm going to do is find the semi-perimeter. So that's a half of 8 plus 6 plus 4, which is half of 18, which is 9. And so now the area using Heron's formula is the square root of the semi-perimeter times semi-perimeter minus A times semi-perimeter minus B times semi-perimeter minus C. So that's the square root of 9 times 9 minus 8 times 9 minus 6 times 9 minus 4, or the square root of 9 times 1 times 3 times 5, which is the square root of 135. And so if I plug that into my calculator, we get 11.62 square meters. And so that's how we use Heron's formula to find the area of an oblique triangle in the side case.